problem 2 is asking us about glucose. So we have glucose reacting with oxygen to produce carbon dioxide and water, and it releases heat. Makes sense. Glucose is an energy source. And we're given a table with heats of formation. And it says that you burn 2,000 kilocalories per mole. How many grams of glucose would you need to consume? Assuming that's your only source of energy. This one just really seems to be a warm-up question. So if I needed 2,000 kilocalories per day, and I can produce 3.7 kcal for every gram of glucose I consume, the units seem to tell me that I need 540.5 grams per day. Now, in the test-taking strategy discussion, I actually recommended that you not do the math. I would have perhaps just written this and not took out my calculator to calculate that. I just simply forgot to stop myself. I do have the answer key in front of me, so I probably should not have. Here, actually, we'll come back and calculate this number later. All right, what is the heat of formation of glucose? Neglect sensible heat effects. So I need to write a chemical reaction for the consumption of glucose, or the conversion into CO2 and H2O. I have a feeling, oh yes, I'm gonna have to do stoichiometric balance, which I hate doing. I shouldn't say that. I love stoichiometric balances. C6H12O6. I'm going to say plus XO2 gives me, I know CO2, well, hold on, let me just write CO2 plus H2O. Notice that the only product that has carbon in it is CO2. And so I believe this is a liquid, at least it would be in biology. This would be a gas. And since I have 6 carbons in glucose, I need to produce 6 CO2. And now to balance hydrogen, notice that water is the only product that contains hydrogen, so I need 6 waters to take care of the hydrogen, and so now I need to choose X so that it satisfies the balance. Let's count our oxygens. So 6 plus 2X, maybe I'll just write that here. 6 plus 2X equals 12. 12 plus 6, that's 18. Okay, I am not gonna calculate X just yet. I'm gonna come back to this later, but to get the delta H of this reaction, I'm going to say that I have, remember, I have heats of formation of CO2 and H2O here. So let me actually just write that out. So the delta H of the reaction, let's see, joules per mole. I'm going to use the same joules per mole. So the delta H of reaction is 2,817,000 joules per mole. And that's an ugly M, sorry. That's the delta H of the reaction. I would expect that to actually be negative because it must be producing energy. It doesn't say that, but if you're producing energy, it should be negative. Oh, it is heat released. Okay. And so this is going to equal 6 times the heat of formation of CO2 plus 6 times the heat of formation of H2O. So it's going to be 6 times negative 285,800 plus negative 393,500. And then we need to subtract the heats of formation of the reactants. Notice that oxygen is an element, so it by definition has 0 heat of formation. And so we need to subtract delta H not F of glucose. So this is what we're looking for. And turns out, hey, actually, I didn't notice this, but we don't actually need to know how many oxygens go into this in order to calculate delta HF. So it already pays off that I didn't solve that because it doesn't show up in the heat of formation. You might need it later, though. Okay, so this is what we would now need to solve for, right? And again, I'm not going to do the math, but it looks like I can do the math and get the answer. So now a reaction results in formation of 1 mole of CO2 at 25 degrees C. The gas is collected in a bag. The pressure of the surrounding is 100 kilopascals. What is the work done when you collect it in the bag? Usually in these questions, you're assuming the bag is so flexible and light that it's really just the atmospheric pressure times the change in volume. So I'm going to write that work is equal to minus P delta V. And remember that initially there is no gaseous product. You just have glucose. So delta V is just the final volume. In other words, the initial volume is 0. So this would just be equal to... should just be minus RT, right? Because if it's 1 mole. And yeah, that should be it. So are we given R? No, we're not given R. If I were writing the exam today, I would have given you R. So I'm just going to say this is equal to 1 mole times 8.314. I believe that's joules per Kelvin per mole. Times the temperature, does it say, it's just 298, 25 degrees C. 299, 298 Kelvin. Kelvins cancel, moles cancel. So we're going to get joules, right? Again, I would not bring out my calculator. Okay, what I would do now is go through the, I'd go to the next problem, because right now I think I've shown that I know what I'm doing on all these questions. I ought to get 6 out of 10 points. I would not spend the time calculating numbers, but just so that this video completes the problem, I'm going to calculate the numbers. So if I calculate 2,000 over 3.7, I should get 540.5. I'm not using a calculator. I'm just looking at the solutions. And so this delta HF is, I didn't leave myself much room. I'm going to erase some. I wouldn't normally erase that, but I don't have a lot of room to write with here. The iPad is not so precise, so I can't write as small as I can with a real pencil. But this is going to be 6 times 393, 500 plus 285, 800 minus 2817000. and this is delta HF of glucose. Let me make sure I got the signs right here. Yeah, when I think this is actually the negative. Yeah, this is actually, I think, positive, negative. That's not what's in my solution, but I think it's actually wrong. I think there's a negative sign in my solution. I'll review that. But this should come out to 1259 times 10 to the 6th joules per mole. And the number, that's 1.2. I believe that number should actually be negative. Don't beat yourself up too much if you don't get negative signs right on an exam. You can see that I'm not so sure I get them right. Okay, now in terms of work, this should just be 8.314 times 298, and this comes out to minus 2424 joules.